Okay, so welcome to Calculus 1. For this first part, I'm going to need to be back here because I didn't realize that the computer's over here and the screen's over there. It's the only classroom I've ever been in that's happened. So let's start off with the little clickers to just kind of give you an idea of what you're going to do with those. Okay. So first thing I'm going to do is I'm going to take attendance. So on your clicker, number 1, or it says 1A, that's yes for us, or yes, thumbs up. And number 2 is no. All right, so everyone hit 1. All right, that's good. That's right. So that's now you were here. Okay. And then the way I'm going to use this is I'll just have this up in the corner, and as I'm going through things, let's say I'm explaining something, like it's obvious to everyone in here that the derivative of tangent of theta is secant squared theta. Yes or no? Yeah. So y'all are lying to me. Y'all shouldn't know what the derivative of tangent of theta is. Right? So you can change your answer. Right? This is calculus 1, right? So tangent theta, derivative, secant squared theta, that should not be something you know. All right? So what I'm going to be doing is, as I'm going through the class, that's always going to be kind of up in the corner. And as I turn around and say, so how are we doing with this? If I see a lot of red, I'm going to have to slow down. If I see a lot of green, I'm going to keep going. All right? That's just kind of a way, because I know people are shy and they don't want to be the one that stops the class. But if I have enough people wanting me to slow down, I will. We'll see how it goes. I used it about 5 years ago. It was okay. I just felt like doing it again this semester. So, all right. So let me get to the business part of this first. So when you come into class, just come in and pick up your clicker. I'll have them up probably on this table. Just grab yours, sit down, and we'll just do that every day. I'm hoping that everyone knows how to get to Canvas. And I'm going to log in. We are not going to go through like every single little detail of the syllabus here. Uh-oh, I don't know if I hit that key. I did not. Oh, yeah, it's different. Sorry. Too many passwords. Okay, so you get into the course. I already sent everyone an email, right, with the first quiz. We'll talk about that when we get to it. So here's our course. I'll kind of, that's as good as it's going to get, I guess, with the brightness on that projector. Oh well. The big thing that you need to know is that if you need to communicate with me, send me an email. This is where it needs to be done. Don't send me an email from your Yahoo account or your Gmail account because it'll get spammed out. I'll never see it. So if you want to send me an email, you go to the inbox over here, and it's 2019, so I'm sure everyone can figure out how to compose a message and send it to me. Yes? And then if I send you something, it's going to be through this system, and it'll appear here on your left-hand side. All right? Let's try those clickers. How do y'all feel about that? Yosef?
Yes.
See? All right. Let's see. I don't remember what number you were. Hold on. Hold on just a second. You're number 25. This is yours. 1 is yes, 2 is no. All right. All right, so let's get out of there and go back to the class. I will introduce myself here in a moment. Go student view so it looks kind of like what you see. With the exception of this pinkish stuff around the edges, this is kind of what you should see when you go in here. Let's just go straight to the syllabus. Again, I don't want to read this because you can all read. The main things, my name is Robert D. Giovanni. I'm a full-time instructor here, so sometimes in college you'll take a class and you'll have an adjunct instructor, which means that they're part-time, which means It'll be kind of maybe hard to meet up with them. They may not have office hours. I do. So if you need to get in touch with me, like come visit me, my office location is here, first floor of this building, okay? And it's JH1110. That's a zero, an O at the end, not a 0. And then I also provide you my cell phone number. So if you need to, let's say you're at home and you're working on a problem, you can't figure it out, what I need you to do is send me a text, okay? Take a picture of the problem that you're working on, take a picture of the work that you have done, and send me that, send that to me in a text. I will be able to reply to it. I've got one of those phones I can write on it, so I can, circle your mistake, or if I need to write up the whole solution, I'll write up the solution, I'll send it back to you. This is the fastest way to get an answer to a question, all right? What I ask though is that first text you ever send me, make sure you include your name and what class you're in, all right? So for this class, it would be, whatever your name is, and then you'd put, I'm in Cal 1 Tuesday, Thursday. That would be enough. And then after that, we'll have a dialogue. You won't have to do that every single time, all right? Good? All right, so that's my contact information, and my office hours are posted here. This is actually the only class I'm teaching on Tuesday, Thursday. So I'm in my office at 9:15, and I'm waiting until this class starts. So if you have any time before our class starts to come by my office, you can come by and get help. We have tables outside of our offices where you can sit down if you want to work together in a group. You can sit at those tables and then come knock on my door when you have a question. I can help you all out. All right? So those are my hours. Monday, Wednesday, I'm also there, but not as much. So, and then on Fridays, you have to make an appointment with me. I'm on campus, but we have meetings and things, so I can't fix a schedule for Friday, like a time, but I can be available if need be. Now the textbook, let's see, can I use this one?
Of course.
Okay, so this is the textbook for the class. This is a very old version. We've been using this for at least 5 or 6 years, maybe even more. Al, did you use this book? No? Okay, so.
We have it in our lab.
Yeah, I mean, you should be able to get this pretty cheap. The good news is that we use this for Cal 1, Cal 2, and Cal 3. So the entire calculus sequence is in here. So even if you had to spend $100 on a book.
It's $200.
Brand new, right?
No, it's used.
This is used?
Yes.
100 at the bookstore?
Yes.
Oh, well, there you go. Yeah, that's why. So I'm sure you can find it cheaper somewhere else, but even $100, you have to take Cal 2?
And Cal 3.
And 3, so there you go. It's like $33 a semester. It's not bad. All right, so get your hands on that book, and you need to have that pretty much right away, all right, because there will be problems out of that soon. If you can't get it, I think the lab has a copy, or you can go and take a picture of your friends. All right, the description of the class I'm not going to go through. You can read through that. We have a lot of things we're going to go through and complete this semester. You're probably interested in your grade, so the grade is broken down, as indicated there. The big thing is the quizzes. Quizzes will come in the form of, you walk into class, I say everyone clear their desk, let's take out a sheet of paper, let's do a quiz. I could just, at the end of class, give a quiz. I could give you a group quiz where you work together. I could let you use your notes. I could send you home with a quiz. I could look around and see there's too many people absent and walk around and do a sign-in sheet for a quiz grade. I mean, they can come in any form at any time. For the most part, a quiz is going to cover any material that we covered in a prior class. So whatever we finish today is fair game for next class. Sometimes I'll give a quiz at the end of class over what we just talked about, but normally that would be a group quiz where you're still allowed to talk about it because you haven't had the opportunity to go home and absorb the ideas. All right? But you are expected the following class to have done your homework, to understand it, and to not have any questions about it. All right? That's up to you. So we have a class on Tuesday. If your plan is to study on the weekend and you're just going to go to class Tuesday, Thursday, and then hope that you do your homework on the weekend, then you could suffer on Thursday on a quiz. Understand? Okay. Exams, 20% each, and then your final is 25%. The final is comprehensive in the sense that it will cover topics from throughout the course, but it will not be every single little thing, all right? Now, you're not going to like this part, but I'm not a big fan of reviews for exams. Now, I will give you a review in terms of like topics, problems to focus on in the homework, but I'm not going to hand you basically a copy of an exam that I'm just going to change numbers on, and that's what you come in and take the test on. Okay, part of this is you as a student becoming a better, I guess, better study habits, learning how to prepare for an exam. And as we get closer to the first exam, we'll talk about, you know, best ways to prepare. Yeah, we'll talk about it, you know, what you should do to prepare for the exam. And I'll give, like, maybe, we'll talk about that next week. How about that? Any questions up to this point? Good? Okay. Policies, you can read through this. There's tutoring available. Okay, this SOBI statement. Okay, this statement, I don't think I've read every word. I think what this means to me is, you know, it's 2019, we live in a crazy world. If you see something weird, you see someone behaving strangely, you need to just like tell somebody, right? And then we also have to, unfortunately, have some idea of what we would do if there was an active shooter, right? Anyone have any idea what we would do? I mean, this is obviously our exit point, right? So there's stairs to the left and there's exit points to the right. But what if we can't get out of the room?
Lock the door, turn off the lights.
We'll lock the doors, turn off lights, barricade. How about the windows? Can we go out? Can we go out these windows? We're on the third floor, right? So your assumption would be no. And you'd be incorrect. So this one is about maybe a 13-foot drop. That window is probably about a 7-foot drop. And you drop onto an awning, and then that awning you could run to the edge and then jump off of there, and you'd survive every one of those jumps. So that window is an exit point, all right? So it's good to know, right? So we have to breach that window. I think we could if we needed to. I've been talking about this like exit points since I started teaching. And back in like 2000s, early 2000s, my students were like, what? You know, I'm talking about like, you know, what if someone comes and shoots up the school? Back in 2000, it wasn't happening. Now it's like, okay, yeah, that could happen. That could happen. So with that said, do we want to keep the door locked? I'm not trying to freak everyone out, okay? It's just, we have to think about this.
Yeah.
Do we want to keep the door locked? Okay?
Yeah.
Yes? All right. So if we want to keep the door locked, that means if you need to leave to go to the restroom, this table is going to be responsible for opening and closing the door for people. Is that all right with y'all?
Okay.
If you don't, then, you know, you can move. So I will keep the door locked. We won't do it right this second, but we'll hope on the first day we're okay. I heard somewhere, I don't know if this is correct, that the only mass shooting that's taken place at like a school where the shooter actually breached a door was the Newtown shooting, where he shot up all the kids because he had to go through the front door. So he just shot through the glass and went right through. So having a locked door is probably a good idea, right? Even though there's a window right there, still it's something between us and them. This is fun, huh? Yes. I want to say this is your generation, not mine, but it's the way it is, okay? All right, let's move on. Where's my calculator policy? Okay, calculators. So you are allowed to have pretty much any calculator with the exception of a calculator that does computer algebra manipulation. So they call them CAS calculators. TI-89, the TI-Nspire CAS is not allowed on any exams, and that's because they can do derivatives and things that we're going to be doing in here. So if you already went out and purchased it and you've got it, I don't want you to go purchase a new one. I will work something out where I loan you one for the semester and you'll have something you can use. Graphing calculator is optional, not required. Scientific, for sure, you need. So you need to be able to take tangent and sine and all that stuff, right? So, all right, attendance, you got to be here. You miss 4 times, I can drop you or fail you. What to expect technology-wise, I'll record every class. So this camera is going to be here every day. It's going to record just what's on that board and me in front of it writing. And then I'll push that out to YouTube and it'll be available later on that day. So the idea here is not that you miss class, okay, because I'll still take attendance. The idea here is you have a flat tire, you have to go to the doctor, you can't be here. If you've ever been in a class before where you missed and you come back and you feel like it's a totally different world, like what happened while I was gone, this is supposed to help that part. That's what it's for. Also, when you're sitting here, you can pay a little more attention to what I'm saying and try to understand the ideas with not just sitting there copying everything and saying, I'll figure it all out later, you know. You can pay attention because you can always go back and review it if you need to, all right? So I'll be doing that. Behavior, I have two big things for this class, sleeping and where's my cell phone? Hold on. Oh, there, yeah, it's electronic policy devices. Okay, so this is kind of a gray area because all the notes that I'm going to be going through this semester, I provide to you in Canvas. You can get to them. I've already had a student ask me, can I use my laptop, right? Can I use my laptop to follow along with the notes while you're in class? That's fine as long as that's what you're doing. I don't expect to see phones out. You know, I go and I walk down these halls and I look in classrooms and I see students on their phones, you know, and the professor's up there going, you know, teaching away, and I'm just like, I don't know how they're okay with that. I'm not. So your phones need to stay away. If you're using your phone during class, being disruptive or sleeping, I'll take off 10 points off your next test. I will ask you to leave. I will count you absent for the day. So that's pretty severe penalties. If you're one of those people who are like, I pay to be here, I should be able to use my phone, then I can transfer you into another Cal 1 class. I have no problem with that. We can get you taken care of if that's what you prefer. All right? Okay, so talk to me after class about that if you don't want to be here. All right, the schedule, I can get to that later. I'm trying to go fast here. Let's see, who just came in? What's your last name?
Garza.
Garza? All right, sir, you might want to sit back here. There's a table here, you can have a seat. And this is your clicker, you're number 11. Okay, every day you'll come pick this up when you walk in, all right? Just have a seat over here. All right, so on our main homepage, the first link you see there is a link to the first quiz, not the one I sent to y'all. This is the quiz where all you're doing is basically signing off on the syllabus. It's saying, I understand what's required, and I need that completed by tomorrow? Yeah, 1 p.m. tomorrow. And it's just a yes or no thing, all right? If you click on schedule, that will download to your PC. Go ahead and print this out, bring it with you. I know it's hard to read. I tried to fit everything onto one page. This gives you kind of a day-by-day, blow-by-blow what we're doing. And this is tentative. This can always change, all right? So today we're supposed to cover 1.1, 1.2, and then to the right you see those list of homework problems. Those are out of your book. So you will go to section 1.1, go to the back of the section, do problems 2, 3, 4, 20, 21, 22, 23. You do all those problems, right? Lots of homework already. Yes?
Here's the date, like, so it's like, it says the date there, and then that's like on the same line.
Uh-huh.
If it's on the same line, does that mean that we have to have that done before the next class? Or
Yeah, so this is Tuesday, right? Right here? Okay, for next class, you should have completed those problems. Okay?
Yes, sir.
And then the next time, it'll be the next 2 lines. Not every single one of these is 2 lines, because we don't cover 2 sections every single time we meet. All right? So those problems are in the book. Print that out. You can see we have an exam. Let's see. Tuesday the 24th. I can barely even read that. Another one in October. And then, oh no, is this before? Okay, at least it's before Thanksgiving. Okay, good. Because after Thanksgiving, most people have shut it down. And then we have finals now. I didn't have the schedule for the finals when I made this. They hadn't put it out there for us yet. So I know that your final is either on Tuesday or Thursday. I'll go make sure I know that, and I'll update the schedule once I know it. It's going to be one of those days, but it's one or the other, all right? So you'll only have to come for one of those 2 days at the end. All right, that's your schedule. All right, course videos. So in this class, I actually have 2 types of videos. Course videos are videos that I made a long time ago that go through the notes that I've created and just give you kind of an introduction to the sections. So if you're ever wanting to kind of get ahead in class, almost like reading before you come to class, you can watch the course videos, and that'll kind of get you familiar with what we're going to do when you come to class. Now, the class lecture videos are what I put here, okay? So that's what, when I upload these to YouTube, that's what I'm referring to, the class lecture videos. And then, the very important, not important, but I guess my students really like this part, is my homework solution videos. So you know you can go buy a solution manual, right? For your book, for the answers to the odds, and it'll show some of the work. Okay, even better, I've worked them all out for you already on video. So you can go, and while you're doing your homework, you can try and do the problem, and then as you go, you can kind of play my video and just kind of see if we're doing the same thing. Now, do not use this incorrectly. Students will go and just, instead of doing their homework, they will watch me do the homework, and they'll be like, yeah, I could do that. Yeah, I could do that. And then they get to the test, and they don't know how to do it because they've never actually sat down with paper and pencil and tried and struggled and curled up, you know, balled up the piece of paper and threw it away and started over. So it's there to help you, but don't use it incorrectly. All right? With me? Questions? All right. And then we have this link to files. I'm going to go ahead and bring up the files. In files, you'll find a bunch of stuff. There's the schedule that I already showed you. This is a worksheet we'll use later. Course notes. So like I said, all the notes I'm going to show up here on the board, there they are. You could actually download them as PDFs, print them out if you'd like, have them with you, paper copies. I'm not going to provide them to you, but if you want them, there they are. Now on your tests, on all tests, you are allowed to have these 6 pages of formulas. These formulas and only these formulas. You can't bring your favorite unit circle from pre-cal. You can't bring some other things that you had in pre-cal or college algebra. Everybody has to have the same set of materials, these 6 pages, all right? So the sooner you print those out, the sooner you start to become familiar with those, the better. Because the formulas that you have in pre-cal, they're here, you just need to know where they are, all right? So there's like algebra formulas, geometry, trig, calculus, it's all here, all right? So print that out as soon as possible. And I actually have some old exams and reviews and solutions and things like that. You know, trust me, I make every exam, every semester I make a new exam, so you know, that is just a guide. You know, you can go there and you can take a look at some of the things I've asked. But in no way, shape, or form is that what you should expect. All right? All right. I'm happy. Anyone have any additional questions or comments? Yes?
This calculator isn't acceptable.
That's okay. That's not the CAS one.
No.
It would say CAS on it, so yeah, that's okay. Yes?
Those formulas for every exam, we can take it
For every exam, you can use them. Yep. Yeah, there's kind of different schools of thoughts on formulas, and I think I'm done up here. Can I get out of here? Can I go over there? I feel like I can. Okay. So there's different schools of thought when it comes to formulas. Some professors are like, you know, no, we shouldn't be giving our students formulas. You know, it's not, they need to memorize them and all that stuff. And I get that. I understand that, but I'm thinking about like the real world. Like, let's say you become an engineer one day, right? And you've got this problem you're trying to figure out. You're never going to be isolated in a room by yourself with no resources, right? You're always going to have something to go to. It's just, you know, how good are you at using those resources? So I look at it the same way here. You know, you have the formulas as long as you can use them. I mean, I've never felt like the formulas are somehow inflating the grades or making students out to be what they're not, if that makes sense. All right. So we got the clickers. How about the little sticks? Let me have your sticks. Collect those together. Leave the Sharpies on the table. I'll get those later. So the way the sticks are going to work is I'm going to make you participate. So every day I'm going to just kind of shuffle these sticks around, and then I'm going to, as I'm going through, anyone else? Oh, y'all didn't get them? Let me see here. So as I'm going through working on, whatever it is we're talking about, I will pull a stick. Oh, sorry, you got it? I will just pull a stick like, is that Michael? Michael Z? See, Michael Z, how are you doing today? Doing good? Okay, so see, he answered the first question of the day. You got lucky, all right? So I'm going to put, it's supposed to make you kind of make sure you're paying attention. And you know what? I know that some of you, that's going to make you a little bit nervous, and you don't want to be wrong, but I would so much prefer that you be wrong here in class than be wrong on a quiz or on a test, all right? So I want to kind of break through that fear you have of being wrong, because calculus, the only way to get good at calculus is by failing at it first. You have to actually fall down and get yourself back up, because that's what this course will do to you. You probably know that already with math, but Cal 1 is where we really start to kind of test your endurance, whether or not you can keep on taking the hits and get back up and go. And then Cal 2 is just like at that point it'll harden you. If you're not hard by then, Cal 2 will harden you. All right? All right, so anything else? We're good? Ready? So what have y'all heard about Cal 1? Were you told to be fearful, or is it okay? What have you heard?
I've heard the trig and the algebra, and it's the hard part.
The trig and the algebra is the hard part. Yes, I've heard that too, and I agree with that. I've always said that calculus is like algebra on steroids. Okay, so like you may have been pretty good at algebra, but then you get here and you're like, oh, whoa. So like for example, if I put this expression on the board and asked you to factor it, I would hope that everyone in here would recognize that that is we call it a difference of squares, right? And that this factors to be x plus 2 times x minus 2, right? Okay, so that's algebra. So in a calculus class, the difference between something like this and a calculus class is, what if we put this here and I ask you to factor that? Most of us are going to sit there and just be like, well, it's factored. Like, there's nothing more I can do with this, right? Agreed? So just tell me if you believe that this would be true. Okay, so multiplying these together, like, right, doing our little FOIL, that would give you x. And then you'd get like this times this would give you like negative 2 root x. And then here you get positive 2 root x. So those would cancel. Then you get this times this. So you would get a negative number, right? But it would be root 2 times root 2, which is just 2. So you would wind up getting this. So this indeed can be factored as a difference of squares. But that's just not something that you normally deal with in algebra. So yeah, this is a different level of algebra, and that's the way calculus will be. There's just going to be everything turned up. I don't believe that the concepts in calculus are really the Achilles heel. It's usually the algebra and the trig. So yes, I agree. That's what I've heard. Anything else? Make sure you study. What do you mean by study?
Make sure you do the homework.
Do your homework, right?
Probably try some of the problems that are not assigned.
Yeah, I mean, if you get through the homework and you feel good about it, try some of the problems that are near them, right? I sent that quiz. How many of you did not get the quiz that I sent as an email? Anyone not have it printed out? I have copies. So I sent an email out, when was it, like a day or two ago? It's okay if you didn't get it. I didn't expect everyone to get it. It's more like a questionnaire, right? I don't want to go through this whole thing right now, okay? I'm going to have this due, this will be due next class. But, I'm talking about, what have you heard about calculus? Okay, I came up with this because I think this is the way I think about calculus. First of all, what's your major, right? Like, Are you engineering? Are you know, everyone's here for a different reason, right? So let's just do this. How many of you have to take Cal 2? Raise your hands. Okay, wonderful. Let's do it the other way, hands down. How many of you don't need Cal 2? I'm sorry to hear that. So I teach Cal 1 as if you are going to be in Cal 2. I mean, that's the way it's going to be, that's the way it should be, all right? Which means that everyone who this is your last math class, I want y'all to latch on to somebody and hold on to them and go for the ride with them, all right? So raise your hand if you don't need Cal 2 again. Okay, so y'all want to find people around you who do need Cal 2 and make sure they can help you out, all right? And then I ask on number 2, why do you want to do that major? I get a lot of students who are like, I want to be an engineer. I'm like, why? Like, I don't know. My uncle's an engineer. You know, something like that. Like, have you really thought about why it is you want to do that? I see a lot of times students want to be engineers, and then they realize that math is difficult for them. It's like, why do you want to continue to throw yourself into this wall? Why don't you do something you're good at and you enjoy, rather than something that is painful to you? So these are just reflection questions, all right? Then I ask you, like, what classes are you taking this semester? I ask you, do you work, right? So show of hands, how many of you work? Okay? Keep your hand up if you work more than 20 hours a week. Okay? So this is another part, you can put your hands down. This is another part of being successful in any class, but specifically a math class, calculus. Do you have too much on your plate, right? There's a reason why you can't go to a university and get a degree, a 4-year degree in 1 year, right? There's a reason why. I mean, you can only absorb so much information at one time. The analogy I like to use is, if you're thirsty, you go to the water fountain, right? You don't go to a fire hydrant. You don't try and drink out of a fire hydrant, right? You can get hurt that way. And it's the same thing here. Like, if you're working so much and you're taking 18 hours of classes, then it's going to be like a fire hydrant, trying to drink out of fire hydrants. So this is more for you than it is for me. And then I ask you to kind of lay out your week, try and figure out, like, yeah, you need to think about it. When are you going to sleep, right? Like, when are you going to have fun? Like, are you going to just do school and work and that's it? Like, balance your life out. You'll be much happier and you'll be much more successful if you have some balance. Yes?
I was back to your, you said to text you for a
Yes.
more question.
Uh-huh.
When are you not available?
Not like
Oh, I am recording. Sorry, I'm listening to you, but I didn't see the red dot. But now I see it. Okay, when am I not available? You can text me.
I'm going to do homework until like 3 in the morning.
Yeah, no, I used to call it my 24-hour math crisis hotline, is what I used to call it, but that was back when I was single and didn't have a wife and kids. So now it's still a 24-hour math crisis hotline, but at night I just silence my phone. And so you're never going to bother me. You can always text, but I would expect that, like, after midnight, I'm probably not going to respond. Yeah, I mean, but that doesn't mean that if you're sitting there crying in a puddle of tears over a problem, that you can't at least try and text me. You might, I might be able to help. Okay. All right, and remember, the homework problems, you have the videos there, right? And I have students sometimes ask me for help on homework, and I'll be like, well, did you watch the video? It's not because I'm trying to, like, call you out, but if I've already explained it on a video, right? If you still don't get it, that's okay, right? But I want you to at least turn to that resource. I put many, many, many hours into that, and so use it, right? Okay, moving on. Number 6, number 6 is the question we're asking you, like, do you really have time for this class? And then I ask a little bit about some classes you've taken in the past, just to kind of know your background. And then number 8, I ask you to try and see if you can exchange some names and numbers with people. You do not necessarily need to fill this out. This is going to be due next class, and I will give it back to you. Number 8 does not have to be filled out, because I'm not going to force you to exchange your phone numbers and emails with people in the class. This is try to encourage you to make friends as soon as possible, because when we work together, we're much more efficient than we are when we work alone. And that's not 100% always, but for the majority of people, collaboration works. All right? All right, and then, number 10. Did anyone get number 10? This is a paradox. So the idea is here is if let's say that I am the person that cuts everyone's hair in San Antonio. This is all theoretical, okay? If I cut everyone's hair in San Antonio who doesn't cut their own hair, then who cuts my hair? So do you have some sort of answer? There's no right or wrong answer. Well, I guess you could be wrong, but.
You drive outside of San Antonio.
Okay, so it probably would have to be someone outside of San Antonio, right? So why can't it be somebody else in San Antonio? Why can't it be? Why can't somebody else, like, why can't you cut my hair?
Because then you would not cut your own hair, and then you must cut your hair because you don't cut your own
That's right. Then, yeah, you would be cutting my hair, but Robert's supposed to cut everybody who doesn't cut their own hair. But you'd be cutting. Okay, so that wouldn't. Can I cut my own hair?
Yeah.
I can cut my own hair?
Yeah, there's people who can cut their own hair.
Yes, but
Cutting your own hair, you're not supposed
Robert cuts the hair of everyone in San Antonio who doesn't cut their own hair. So if I cut my own hair, I'd be cutting the hair of somebody who cuts their own hair. Right? It's a logic problem. I just wanted to see if you understood like the problem with this question. It's
What if there's more than one answer I gave you?
oh, that's okay. I'm just curious to see. I'm just more curious to see what people put.
You still accept this because
Change my name. Right?
everything out, it's already ready to go.
No, turn it next time.
Okay.
Yeah, just so I have them all together. I'm notorious for losing things, so I'd rather have them all together.
Again, it's still acceptable that it's typed
Yeah,
out, right?
absolutely. Okay. All right, I think we're ready to roll. So that quiz, fill it out, turn it in next class, yes? All right, so Calculus 1, what are we going to talk about here? Well, there's one fundamental underlying principle. And I want to talk about Cal 1 like broadly first to see kind of where we're headed. And then we're going to have to go back and do some review and all that. But just what is the big question that we're trying to answer in Calculus 1? All right? What's the big question? So here's kind of leading into it. If I ask you right now what 0 divided by 4 is, what would we get? 0, right? Okay, so if we have 0 in the numerator and a non-zero number in the denominator, the answer is always 0, right? Okay, that's fine. Okay, so what if I flip that over? What if I put 4 divided by 0? So that's called undefined, right? In our numerical system, in our mathematical structure, our system that we have, division by 0 is not allowed, right? And we're not going to get into a big, deep discussion about that. We're just going to say this is undefined. All right? All right, one more. What about this one? 0 over 0. So this, you kind of run into a little bit of an issue here because there's kind of like simultaneously there's a bunch of things happening. You were told at some point that if you ever have like a number over itself, that should be 1, right? So like anything divided by itself is 1. Like in general, x over x should be 1, right? I'm going to leave a question. Is that really true or not? We're going to just say it is for now, okay? But anything over itself is 1, right? It's kind of burned in there somewhere. So with this, we actually do have something over itself, right? So should it be 1? Well, maybe. But we also have 0 on top, and we've been told that if 0 is on top, it should be 0, right? But then we also have division by 0, which should be undefined. So do you see it's like all these different things at one time? So this right here is actually undefined. All right, it's undefined. And the reason why is because when you learn all these rules, like when you're told that anything over itself is 1, there's a little asterisk that they don't necessarily always point out. And that is anything over itself is always 1 so long as it's not 0. Okay? Yes?
So is no solution and undefined, they're not the same thing?
No solution and undefined are two different things. Yep. To say no solution means that you started with an equation. Okay, and this is not an equation, this is an expression. So it is just undefined. It's an undefined expression. So when we're doing this, the little asterisk said, okay, so long as we're not talking about 0 over 0. All right? And the reason it's not this one is, again, because this rule only works as long as the denominator is not 0. So that's kind of why it looks like it's a couple of things, but it's really just ultimately this. It is division by 0, which is undefined. But this right here actually is going to have meaning to us, all right? It's going to have meaning. And we're going to see that we're actually going to be able to get like numerical answers when we see things like this, all right? There's a little, I have an asterisk next to what I'm saying. You're going to have to stay tuned. But let me motivate the idea a little bit. Before, you know, when is this ever going to come up? Why would it be important? Who cares, right? So let's take a look at something. You may be familiar with this, you may not. When you talk about the speed of something, average speed, sorry. Does anyone know what the average speed of an object is?
Is it due by gravity distance?
Total distance you travel,
Oh, okay. Never mind.
okay, divided by the total time. And little side note here, what I'm putting up here today is just kind of like random ideas coming out of my head here. My notes are more structured, okay? So we are going to get to more structured stuff, but for now, I'm just trying to get you somehow excited about this. So the average speed of something is the total distance divided by the total time. So let's say you drove to school today. Let's say that you live kind of far away. So let's say here's time and here's distance. Then you start out right here. So at time is 0, you start your clock, right? You're about to start moving your vehicle. You start traveling, time starts, you move, and you're going to start traveling a certain distance, right? And at the end of the time, so you have some sort of graph here, you've gone some distance. Let's say it was 20 miles. And just for the sake of simplicity, let's say it took you 1 hour. All right? It's a lot of traffic, I guess. All right? 20 miles took you an hour. Then what is your average speed? So your average speed, this right here, I'll use a different color even though this right here, would be your total distance, right? What would the total distance be? How far did you go? 20 miles, right? So 20 miles divided by the total time, which was 1 hour, right? Which would then be 20, I'll use MPH, that's what we're used to writing, right? 20 miles per hour. That's your average speed. Does that mean that at every moment when you were driving, you were going 20 miles an hour? No. It's saying on average. So when we come back over to this graph, let's look at it more from like an algebraic point of view. If we look at these as points, as ordered pairs, what's that point? 0, 0. And what's this point? 120, right? Right? Okay. Back in algebra, if I was asking you to find me the slope of the line connecting 2 points, could you find the slope of the line connecting 2 points? Right? The slope of the line connecting 2 points, we use m for slope, is rise over run. In this case, what's your rise? It would be, we almost could look at it like a triangle, right? The rise would be the difference of these, which would be 20. So you get 20, that's your rise, over your run. What's your run? Is 1. And look, these are not coincidentally the same answer. You could look at your average speed as the slope of the line connecting these 2 points, right? So it's like saying this person, when they drove to school, they sped up, slowed down, right? But at the end of the day, it's the same as someone who just started driving 20 miles an hour and just drove 20 miles an hour the whole way and then came to a stop. Those two distances covered and times it took would be the same for both. Does that make sense? So although this number is valuable to us, it doesn't really give us any information about what's happening at a particular point in the actual trip. So let's say I take some arbitrary point here, I'm going to call it x, and I go right there, and I ask you, hey, how fast were you going right there? How would we do that? So I'm asking you, what would your speed be at that instant in time? And as soon as I ask that question, we run into a huge problem. Because if I say, what's your speed at an instant in time, and speed is defined to be the distance you travel divided by the time you travel, then at an instant, are you going anywhere at an instant? Like you're moving, but if I just like to imagine like some object moving, you just take a picture, right? And at that instant, when you take the picture, we know it's moving, but what's the speed at that moment? The problem we run into is that if we try and define the speed here, then the distance we travel would be what? At an instant, what's the distance we travel? Are we moving?
Yeah.
We're not moving, right? So the distance we travel would be 0, and the time it takes would be 0 also, and we get this 0 over 0. Which for a long time, that was acceptable. It was like, okay, we can only talk about average speeds. You have to have 2 points to be able to talk about speed. But Isaac Newton, who is the father of calculus, along with another gentleman, Gottfried Leibniz, the two fathers of calculus, they were asking, no, there's got to be a way that we can talk about the speed of the object at an instant. Now for us, when we're driving down the road, we can do it, can't we? We just look at our speedometer, right? And that's giving us our instantaneous speed. But that's because there's gears turning and stuff like that, and well, it's probably all electric now. But in terms of the definition of the speed of something at an instant, you're always going to get 0 over 0. But Newton said there's got to be a way. Leibniz said there's got to be a way. Do you kind of understand there's a problem, maybe there's a way around it. So I'm going to give you maybe a more concrete example that might convince you that we can actually get an answer. Let's take a look at a function like this one. Right, so we should recognize that from college algebra as a rational function. Not super important that you remember that it's called a rational function, but it's a polynomial divided by a polynomial. All right, so let me ask you a few questions. Let's say, what is f of 4? So what would happen if we plug 4 into that function? What would we get in the numerator? So we get 4 squared, 16, take away 4, we get 12, right? On the bottom we get 4, take away 2, we get 2. So we get 6, right? So if we plug 4 into this function, it's going to spit out 6. Agreed? So if I were to go and try and graph this, I know at 4, I have a y coordinate of 6. So that point lives on the graph of this, yes? All right, well that's not interesting at all. So what's f of 2?
0, 0.
Yeah, so we're going to get 0 over 0 here, aren't we? 0 over 0, which is undefined, right? Now in college algebra, we would call this a hole, wouldn't we? We'd call this a hole in the graph. So that means if I go to 2 on my graph, I have nothing, right? There's nothing here. There's no point that corresponds with that input. So what I'm going to do now is I'm going to go to my graphing. I'm going to go to a website called Desmos. Has anyone heard of Desmos before? Desmos is this pretty cool graphing software. It's not software, it's a website. You just type in your function. So I'm going to go x squared minus 4 over x minus 2. And that's the graph right there. See if I can line it up with mine. Okay, so that is the graph of that function. So I want you to pay attention to something. At 4, the value of the function is 6, just like we said it would be, right? At 2, what's the value of the function? Can't be 4 though, right? It's undefined, right? The computer isn't letting you know there's a hole there, but there is a hole there. There is no graph there. So like technically, if I'm trying to draw this with my pencil, I'm supposed to draw and then pick up and then continue, right? There is a hole in the graph. So at 2, we're undefined. But what about if we're anywhere close to 2? So imagine you're just a little bit to the right of 2. Let's say you're here at 2.1. Sorry, I wrote that real small, 2.1. If I plug 2.1 in there, am I going to have 0 over 0 anymore? I'm not, right? I'm actually going to have an answer. What if I plug in 2.01, that's even closer to 2? Will I have an answer? Yes. What if I plug in 2.001? I would have an answer, right? What if I go to the other side of 2 over here, and I plug in like 1.9? Will it work, or will I get 0 over 0? It'll work, right? I'll get some answer, right? Now, you could right now, if you wanted to, get on your calculator and start plugging these in. I'm not going to ask you to do it. Let me see if I can just use the computer to do it. Sorry, I'm trying to make it so you can see over here. Okay, see at 2.15, can you all see that it's 4.16? If I try and get this closer, it's going to drive me crazy. They put these new glossy boards on here for us, and now my mouse doesn't work on the board anymore. So I have to zoom in here. So I've kind of lost it here. Move it over. Okay, so if I'm at 2.14, you see I'm at 4.14, and try and get closer. Notice the y coordinates. What are the y coordinates all very close to? They're all close to 4, right? I'm trying to get closer. 2.05, I'm at 4.05, right? So even though at 2 I'm undefined, if I'm just a little bit past 2, there's an answer. It looks like it wants to be 4, right? If I go to the other side, over here, and I start getting closer to 2 from the left side, like 1.97, 1.985, look at the answers. 3.985, that's close to 4, isn't it? So, I mean, visually we can see that as our x value, let me see, this is 2. Wait, I'm down here, 2. Here's 2. At 2, no go, right? But as we approach 2 from this side or from this side, we get an answer that corresponds, right? It looks like it just wants to be 4. And that's, believe it or not, that's what calculus is about. It's about, instead of doing what we did in algebra, where we say, go to 2, look at 2, and forget everything else. What we do in calculus is we say, forget 2, what's happening near 2. That's calculus. 2 completely different perspectives. I saw an analogy of this many years ago. You know, let's say you have a window and you have like shutters on that window. Okay? You'll know what I mean by shutters? Right? So right now I can't see out the window, can I? It's closed. If I open this up, then you can see through the window, right? In college algebra, what we do is we look at a specific x value, which would be like right here, and we close the shutters and we just look at what's happening right there with a little strip of lights coming through. That's what we focus on. In calculus, we open up the shutters and we ignore this middle piece and we talk about what's happening near the edge of that vertical line. We'll get more into this, but that's the approach that Newton had to take to somehow work his way around this, all right? All right, so Then you might ask yourself, well, why would that be important, right? Like, who cares if you can figure out what 0 over 0 kind of means? Well, here's where it's going to lead us. This is probably one of the most fundamental things that we'll do. Do you remember in college algebra that if you were given a parabola, you could always find this point right here? We called it the vertex, and they gave you a formula, didn't they? There was a formula. You may or may not remember it, but the vertex formula was that if we call this the point hk, that h is equal to negative b over 2a, and then k is equal to f of h. That's not important that you know that right now, but that's the formula that we had, right? And that allowed us to find the highest point on a parabola that opens down or the lowest point on a parabola that opens up, right? And nobody really asked where that came from, but that formula was given to us, right? And then as you moved on in college algebra, you started studying things that were higher degree than quadratics. You would do these like third degree polynomials, right? Something like that. And maybe you found the x-intercepts of this, right? Figured out the left and right hand behavior. What did you not do? You never figured out what that point and that point were, right? You never did. You never tried to figure out where these little humps and valleys were. You were not able in college algebra to actually tell me how high that point is and how low that point is. On a parabola, we can do it, there's a formula. But once we get past parabolas, we stop doing it, didn't we? This is what calculus will be able to do, is it will allow us to take any function, not just polynomials, sine functions, log functions, any function you can come up with, and you can find these little peaks and valleys. We'll call them maximums and minimums. So why would that be important? What's that? Yeah, anything you can think of that has a function to it, you can find these critical points that would serve some, function to you. The thing that always comes to mind for me is something like, how far do I want to stretch this? I don't think I want to stretch too far, but I'll at least set it up. Let's say this is a river, okay? Let's say that we have a building on this side, building A, and we have a building on this side, building B. Now let's say that we need to connect building A and building B together. Oh, I need to tell you how wide it is. Let's say this is a 300-foot river. And let's say that the distance downstream, let's say that's 1,000 feet. I'm just throwing numbers up here. I need to connect these two buildings with fiber optic cable, all right? So my company, your company, is the company that's going to do this, right? So we have to put in a bid to, let's say, the city or whoever wants this done. We have to go put a bid in for them, right? To see how much we would do it for. Well, what are the different ways we could do it? We could go straight from A to B, and everyone would say, oh, that's the shortest distance, right? Agreed? Yes. But the problem is that when you go from A to B, that means you're going directly, you're going to have to go under the river. Okay, so you have to burrow down under the river, and that's going to be more expensive than it would be to just go straight across. Do you all understand that? So like if I go from here to here, that's a long way to go under a river, right? Maybe it's more efficient for us to go down, like across, and then straight across like that. Maybe that's cheaper. Or maybe it's some combination of the two. Maybe I should go here and then across. That's all going to be dictated by how much it costs you to go above ground versus below ground. So imagine we're sitting here, we've got our company, we've got all the engineers sitting at the table, right? What we want to come up with is a function that gives us our cost. If we can somehow come up with a cost function, if we can somehow determine it, then we can graph it, right? And if we can graph it, then what we're interested in is that point right there, right? Because that point will tell us how we will get our lowest cost. And to be able to find the lowest point on a function, you need calculus. You have to have it.